So in example 5, we're going to switch in 6.12 still. We're going to switch to looking at what happens when we have a quadratic factor. If you do run out of space on this one on this page, which I did give you about half a page, we aren't going to do example 6 over here on this page. I decided that one was a little bit too much. So you can use that space on that other page if you need to. So we've got partial fractions with a quadratic factor. So let's look and see how we deal with this one here. So this is just more of a how do we deal with the partial fraction decomposition is a little bit different. In this piece here, I know I could take out an x and I've got x minus 1. So I am actually going to have 3 factors this time. I will have an x, I will have an x minus 1, and I will have an x squared plus 4. So something that we didn't talk about when we did the partial fraction decomposition lesson is that when we have a quadratic factor, we have to, whatever's up in the numerator has to be 1 degree less, meaning I'm going to have an x in this numerator here when I do that integration. So the way that I set this up, I'm going to need a little bit more space for my calculus this time. So I have a over x plus b over x minus 1. And if you think about it, those are x to the zeros, right? So that's 1 degree less. So for my quadratic factor piece, I have x squared plus 4 on the bottom, and the numerator, I need to figure out cx plus d. So that's what we went 1 degree less. And as far as your constants are concerned, you just go you just keep going. We don't want to repeat any of those constants. So let's take a look at getting these equations written. So I know I have 2x cubed minus 4x minus 8. You'll notice, I'm going to do that one more time. We skipped a term. So technically I have 0x squared plus, minus at 4x minus 8. All right, so now I'm going to start the multiplying. This one here, I have to multiply by, I have to multiply by whatever I'm missing, same pattern. So I'm missing the x minus 1 and I'm missing the x squared plus 4. So I'm going to do this off to the side for a minute. X minus 1 times x squared plus 4. So when I FOIL that together, I get x cubed minus x squared in the middle, and then plus 4x minus 4. So that's what I am distributing in. So I have ax cubed minus ax squared plus 4ax minus 4a. Then I'm going to multiply this one here by x times x squared plus 4. So I'm distributing that bx. So plus bx cubed plus 4bx. Then I am going to distribute, for this one here, I would have to distribute, or I'd have to multiply by x times x minus 1, which we already know when we multiply that, we get this here. So x squared minus x, and instead of just distributing, I'm actually going to FOIL. And I wrote way too big. I should have written smaller to squish this. So plus cx cubed. So that's the firsts. I'm going to go with my outsides next. So plus cx squared, and then my insides plus dx squared, and then minus dx. And that seems massive, but it really I don't think is as bad as it seems once we kind of break it down a little bit. So first of all, I need a cubes equation. So let's find all my cubes. I believe that's all my cubes. So my cubes are 2 equals a plus b plus c. And then let's do a squareds equation. Let me find all my squareds. There's a squared, there's a squared. So, didn't have a b squared. Let's see. Double check my sheet. Nope, did I have a c squared really? Yes, I did. Okay. All right, let's see what happens. So we've got 0 equals negative a plus c plus d. Okay, and then let's do an x equation. So let me find my x's. So I've got negative 4 equals 4a plus 4b minus d. And then finally we need a constants equation. So I'm starting with negative 8 minus 4 or equals negative 4a. And that's it, right? So that's kind of the starting point, right? Because once I get a, I should hopefully be able to get some of these other things. So I get that a is equal to 2. So I'm going to start plugging that in where I see a's. So I've got 2 equals 2 plus b plus c. I'm going to subtract that 2 to the other side, which gives me 0 equals b plus c. All right, let's see if I can narrow this down a little bit more. So I'm going to go here, and I'm going to plug in that a. So I get 0, oh, not 0. I am going to get negative 2 plus c plus d. So when I add that to the other side, I get 2 equals c plus d. And then here, I would get negative 4 equals, I put a 2 in there, I would get 8 plus 4b minus d. I'm going to move the 8 to the other side. That's going to give me negative 12 equals 4b minus d. Okay, so now I need to figure out what else I can do with this. It looks like I can take this b and move it to the other side, and that will give me c. So I know that negative b equals c. So I'm going to take that and I'm going to substitute it in here. So 2 equals negative b plus d. And you'll notice now I have two equations. One has a b and one has a d, and that was a terrible choice of highlight. So I can't read it. So now I'm going to redo all of that, which is, it was a 2, right? And then this one was 12. Okay, so it looks like I already have opposite signs, so I'm just going to take this one and just write it right under here to add them up. So 2 equals negative b plus d. So I'm using the elimination method, so I'm getting negative 10 equals 3b. Oh boy, fractions. Hopefully I'm doing this right. So negative 10 over 3 equals b. So this is not the answer I got before. All right, so I paused really quick because I went through and I knew I had to have some kind of mistake somewhere, so I figured out the mistake. When we were up here and we did this distribution and this multiplication, when I multiplied this one times this one, I missed a negative sign. So I had to fix that negative there, which meant that this here had a negative in front of it, which meant this became negative, which means it's a double negative, which is positive. So let's switch this to a positive. And then much, much better, 4b plus b is actually 5b. So then that means that b is equal to negative 2 when I divide that. So much better. So I now have that a is 2, b is negative 2, and then I'm going to put this back in. I can put it in here. So negative 2 equals c. So that means that c is equal to 2. And then that d, if I put it in this one here, 2 equals, that's going to be double negative is positive 2 plus d. And the good news is that d is actually equal to 0. So I don't really need to worry about adding anything there. So now I'm ready to do the calculus piece. I'm ready to integrate. So when I integrate this first one, it's like a 1 over x. So 2 natural log absolute value of x minus 2 natural log absolute value of x minus 1. And then this here, think about it. It's good old U substitution, right? So U is equal to x squared plus 4, meaning that du equals 2x dx. I have the 2x dx, so I don't even have to really do anything. If I was thinking about my U sub, it would be 1 over U. So when I integrate 1 over U, I get the natural log absolute value of U plus c, and I could just sub my U back in there. So x squared plus 4. So one other quick thing, if you just look at this at the bottom, take a minute, pause the video, look at these two, and decide what you would do to integrate them. Just take a minute and think about it. Now that you've thought about it, I'm going to tell you what I thought about them. I'm not going to do them. We're not doing them. We're just talking about what method we would use. So on this one here, I would probably use a U substitution because I know that when I take the derivative of this, I get 3x squared plus 3, which I could factor a 3 out, and I get what's in the numerator. On this one here, I would use our new method of partial fractions. It's not an easy factoring in the bottom, so I'm not going to even attempt it because it took me a while to figure it out. But there's no other method that it really fits, so I'd have to try to use partial fractions on that one.